With every data structure we've looked at in this course so far, the ability to enumerate nodes in a well-defined order has been important. For a linked list, we could enumerate from left to right or right to left. For a stack, we would enumerate in a last in, first out order, and for a queue, in a first in, first out order. But for a tree, it's not quite as obvious what to do, and that's because trees have multiple links, potentially at every node. So when you're at that node, should we go left first? Should we go right first? And really, you don't need to pick one over the other. You can pick all kinds of varieties, and we'll look at three. So these tree traversals enumerate nodes in a well-defined order. The basic algorithm is you process the node that you're on, and then you visit the left node, and then you visit the right node. And at each of those nodes, you follow that same algorithm. Process the node you're on, visit the left, visit the right. What varies between the different algorithms is the order in which we do those three steps. And the three common orders that we're going to look at are pre-order, in-order, and post-order. So let's start by taking a look at a pre-order traversal. And we're going to visit the root node of this tree. And we want to traverse these items in pre-order. So we start with the value 4. Well, 4 is not null, so we're going to process that value. As you can see, we've now processed the value 4, and I've indicated that along the bottom. Now we're going to visit the left node. So now we've started over. If the left node is not null, we process it, which we did. And let's go to left again. And now we've processed it. Now if we try to visit the left node, we will find it's null because there is no node to the left. So we would now visit the right node, which is also null, and we return. So now we're back at the 2 node, and we've already visited the left, so now let's visit the right. That causes us to process 3. Again, it has no children, so visiting left and right don't do anything. We return from 2, which is now processed left and right, so it returns back to 4. 4 is now going to process its right side. It starts with the node 6. The 6th node has a left child, so it visits that. That child has no left or right children, so it returns. And the 6th node now processes its right node, which has no children, so we're done. So a pre-order traversal processed the nodes in the order 421, 3657. And this might look somewhat random to you, but what's important is that the enumeration order was stable. We could enumerate this tree using pre-order traversal 1,000 times, and each time it will enumerate in this order. Now, an in-order traversal is something that I think most people, when they think of how they want to enumerate, they go for. So what happens here is we visit the left nodes first before processing, and that has an interesting characteristic that I think will jump out to you pretty quickly. So we'll start with the root node, and we visit the left node. And now we're going to visit its left node. And since it has no left node, we'll process it. So we process node 1. It has no right node, so we return. Once we return, we can now process node 2. And now we'll visit its right node, which has no children, so it gets processed. And then we return back to 4. We can now process it because we visited the left. Now we visit its right. At the 6th node, we visit the left, which is the 5 node, which has no children, so we process it. It has no right child either, so we go back to the 6th node, process it, go to the 7 node, which has no left, so we process it, and then we're done. And in this case, we've been able to print out the tree or process the tree in sort order. The tree is not stored 1, 2, 3, 4, 5, 6, 7, but we're able to process the nodes in that order. So an in-order traversal is very commonly used when you have a tree and you want to look at the items in sort order. Finally, we have post-order. So what we're going to do here is start at the head node. We're going to visit left and then visit left again. Now we'll process that node. Now we're going to come back and we're going to visit right and process that node. Come back and now we can process there. We come back to 4, Oh, now we have to visit the right, so let's visit the right, which visits the left. It has no children, so we process it. We return back to the 6 node. It has a right child, so we visit it, which has no children, so we process it. We return, we process the node, we return, we process the 4. So now we've seen 3 different traversal mechanisms: pre-order, in-order, and post-order. In-order is the one that I think most people look at and say, hey, I understand that, I can see why I want to use that. But both pre-order and post-order do have well-defined uses. They're often used in mathematical expression evaluation, and they're also quite often used when you're doing evaluation of runtime behaviors in a language. For example, compilers use trees quite heavily, and traversals dictate which operations happen in what order and what operations depend on other operations. So if you think of this as a dependency graph, what we're saying is steps 1 and step 3 have to operate before step 2, and steps 5 and step 7 have to operate before step 6. And then step 4 is the last one to operate because it's the parent. It's operating on the sum of the operations of all of its children. I would encourage you to spend some time learning more about the traversal mechanisms and seeing some of the contexts that they're used in.